Hello, cherished learners. Welcome to St. class. It's another edition of St. class. Welcome you all. If it's your first time of watching our video, kindly subscribe to our channel, like, and then share our videos to your friends. Today we are taking some lessons for core maths for the senior high. So this is SHS 2 online class. We know the senior high two students are home now, so we took the opportunity to take you through some topics in English, in core maths, in social studies, in science, and also government and history for the general arts. Yes. So, you're welcome. Let's look at variations today. Variations, in other words, proportion. Now, the word variation in maths simply means, or when you go to even the dictionary, if you want to say the meaning of variation, simply means a change. A change. Something varies. A change. It differs. Good. So in maths or in business or in science-related field, variation simply talks about the relationship between two quantities, where a change in one of the quantity will also lead to corresponding change in the other quantity. So variation means, or variation is the relationship between two or more quantities, where a change in one quantity leads to the corresponding change in the other quantity. That is what variation simply means. System where a change in one quantity affects the other quantity, resulting to a change in that quantity. That is variation. Good. Now, I'm going to use examples to explain it for you to get the understanding much better. For example, let's assume I have a mathematics textbook and then I want to sell it out to you. So the cost of the maths textbook is 50 Ghana cedis. The cost of just one is 50 Ghana cedis. And then you say, oh, Sir Henry, I want to purchase two of the maths textbooks. So what will be your price? 100 cedis, right? Good. So you simply multiply 2 by 50 and that will give you what? 100. So if you are buying 2, meaning you are paying 100 Ghana cedis. If you want 1, you just 50 cedis. If you want 3, meaning that will be what? 150. 4, 200 in that order. That's what we term as variation. So here the change in the quantity will affect the change in the cost. Because if I want just 1, it's 50. So just one quantity, 50 cedis. So the quantity increases, the quantity is decreasing, but the cost increases. So if I still want to, the price is still what? Increasing, variation. So a change in this is also affecting this. So when I add 1 to this, the cost also increases. When I take 1 out of it, the cost decreases. Yes, so that's how it is. That is variation. Very, very simple. Very, very simple. Also, if I have y is equal to 2x, y is equal to 2x. So if I want y, 2 multiplying x, and let's say x is 2. So that will be 2 times 2, and that will be y to be equal to 4. So if x is 1, meaning y, 2, 1, 2, so y is equal to 2. Good. So a change in one quantity results in a change in the other quantity. That's what we term as variation. And variation is used in science field and business related field. Now, let's look at the types of variation. There are 4 types of variation. So there are 4 variations to be treated in the senior high 2 syllabus. Direct, indirect, partial, and joint. We'll quickly take direct variation and look at what direct variation is. Direct variation, in other words, direct proportion. Now, what is direct variation? It is a form of variation where a change in one quantity results to a direct change in the other quantity. So here, if there's an increase in one quantity, there's also an increase in the other quantity. or if there's a decrease in one quantity, there's also a decrease in the other quantity. So here is directly. So here we say x increases or decreases, y also increases or decreases. So here, whatever happens to one quantity affects it, but they move directly. Not that one increasing, the other decreasing. No, if A is increasing, B also increases. If C is increasing, then D also increases. If X is decreasing, Y decreases. If X is increasing, Y increases. That is direct variation. Very, very cool and very, very simple. Leave your following. Good. So for example, let's say I have a book. Yes, the cost of one book is 20 Ghana cedis, just one. So if I want two, that would be 40 Ghana cedis. So as the quantity is increasing, the cost is also increasing. Yeah, I just had one to be 20. One has been added, so the quantity has increased. The cost will also increase. Direct proportional, direct variation. Very, very easy and simple. Believe me, you get it. All right, so let's continue. So there are some terms that I'm going to get. So with what I've just written here, I can see x varies directly as y. This a statement. I need to write it in mathematical notation. That will be x. This is the symbol for variation. This way. So variation is written this way. This is how I write it. X varies directly as y. This is how we write it. I need to express this in an equational form. So this can further be equated as x is equal to ky. And I'm going to explain the meaning of the ky. So if you want to write this variation in equation form, x is equal to ky. What is this k? This k is a constant. We call it constant of proportionality. Constant of proportionality. And what is this constant of proportionality? The constant of proportionality is a figure or amount that does not change with respect to the question. It is fixed in the question. Here, the cost was fixed at a price of 26. Whether you are buying 5 quantities or if you are just buying one, the cost of one is 20. That is what the constant of proportionality. So constant is the fixed number or the fixed amount. Good. That is the key. Always, if you want to write an equation, the k comes first. Always it should come. It should always come followed by the other quantity. That's very good. Now let's note the following. So note the following. If I say x varies directly as the cube of y, how would you write it? Cube of y. Cube means a power of 3. So this will be written as x varies, variation, directly as the cube of y. The cube of y is y cube. Then you write it as an equation this way. So that will be x is equal to ky cube. If I also say z varies directly as the square root of let's say v. Square root of v. Square root is the square root of v. So that would be z varies directly as the square root of in equational form, this is your k. So this is not coming in k, and then your root v. Very simple. So these are some 1 or 2 things that you should know. We are going to solve some questions. And note, the graphs of direct variations are linear. They are straight. They are very straight. So if I want to draw a graph of it, it goes this way. Notice y, and this is x, and this is y. Mostly they are linear, straight. Because as this one is increasing, the other increases, increasing, in that order. So this one is decreasing, in that order. Let's solve some questions here. I'm going to write some examples and we try and answer to get a much better understanding of the topic. One, V varies directly as I. When V is equal to 10, I is equal to 5. Find I when V is equal to 100. So the question says that. So first, write the first statement. V varies directly as I. And we learned how to write it. Good. So here is V varies directly as what? I. You write it. And it further says, so you write it in an equational form. So that will be V is equal to, I know you have experienced, K I. Very good. Now it says when V is equal to 10, I is equal to 5. So V equal to 10, I equal to 5. So here, V's value is 10, I's value is 5. We need to find a constant. The question hasn't given. Sometimes the question would give you questions where it contains word problems. But here the constant K, constant of proportionality has been given. You need to find it using these two values. So let's do a quick substitution. So V is equal to Ki. Then what do you think? So V is given by 10 equals K, which we don't know, times I, which is given by 5. Since we want to find K, we divide both sides by 5. So K is equal to, so 10 by 5 is 2. So the value of K is 2, the constant is 2. Now the next question says that find I when V is 100. So we find I when V is 100. So when V is equal to what? 100. And your K, what is your K? 2. I, do you know I? Don't know I. So I'm going to use the same equation. You are using a common equation. Here you found K. Now here they're giving you only V. Use this and the K to find I. Very simple substitution. So your V here is 100. You don't use the other one. Here they're giving you a different value. So V is 100. So 100, replacing the V, K, which is 2, times your I, which you don't know. So we want to find I, we divide both sides by 2. So I is equal to 100 by 2. Half of 100 is 50. So therefore, I is equal to 50. So we say therefore, when V is equal to 100, I is equal to 50. And then you are good to go. Let's go to the second one. A car travels 330 kilometers in 5 hours within a uniform speed. In how many hours will it travel 4,290 kilometers? So here, a car travels 330. So the 330 is in kilometers. That is its distance. 5 hours. T time. 5 hours. In how many hours will it travel 4,290 kilometers? So here we can see Distance varies directly as time. Because we are talking about distance and time. So D varies directly as T. Then in equational form, D is equal to KT. So the distance is 330, time is 5. Let's find K. So 330 is equal to K, which we don't know, times T5. Divide both sides by 5. 5 equals 5. So K is equal to, this will give us 65 hours. Sorry, it's K. Let me also chip in this. Then K does not have any value. It's a constant, just a whole number without any value. Sorry about that. So 5 into 30, yes, 330. So 5 into 30, 6 times. So 10 into 30, so remember 3. So 6 times. 5 into 30, 5 into 30, 5 times. Sorry, it's 66. Right, yes. So 5 into 36. Then another 35 into the next 36. So 66. 66. Yeah. But you're not done. That is for key. So the next question says that in how many hours will it travel 4290? In how many hours? So we have to find the time which we don't know. In 4290 kilometers, so that happens to be the distance. And K, which is what? 66. So using the same equation, D is equal to KT. So we see 4290 for distance, K, which is 66, times RT, which you don't know. Divide both sides by 66. 4290 by 66, 65 hours. Is that true? Let's see. 66 by 65, this is 30, 30, 36, 18, 21, 30, 36, 36 plus 39, 0, 8, 9, 0, 9, 9, 2, 4, so 0, 9, 12 plus 1, 4, 2, 9, 0. Yes. So the answer is 65 hours. You can also do this in a different way. Very easy. So the distance 330 kilometers. If 330 kilometers will give me 5 hours, then 4290 kilometers. How many hours? 8 hours. So you cross multiply. So 330 x 4290 by 5. And I still tell you the answer is 65 hours. The last one for direct, I'll move to the next one, indirect. R varies directly or linearly. Is another word for the direct variation is linear variation. Varies directly as the cube root of R. R varies directly as the what? Cube root of what? V. So this is the cubic root. Okay, so R is equal to K root cubic root of V dot x. So when R is 5, V is 125. So R 5, V 125. Let's use this to find the key as we always do. So R is 5, K which we don't know, cubic root of 125. So 5 is equal to K. What's the cubic root of 125? There's a number that multiplies itself twice to give you 125, and that is 5. So 5 is equal to 5K. Using k is equal to 1, let's find the value of r when v is 8. R when v is 8, using the same rule. So R8, K, which is 1. Sorry. So R is what we are finding. R first, K, which is 1, and then cubic root of 8. So R is equal to 1. What's the cubic root of 8? There's a number multiplying itself 3 times to give me 8. That is 2. So R is equal to 2. So when V is equal to 8, R is equal to 2, and you are good to go. This is all about direct or linear variation. Very easy and simple topic in mathematics. This is Henry's class. Keep enjoying. Now move on to the next thing, indirect variation, before we bring today's lesson to an end. Yes. So keep your fingers crossed. Let's move on to the next thing. Indirect variation. In other words, inverse variation. Here is different from the direct. When we say something is inverse, meaning the opposite of the opposite. Yes. When we say the inverse of something, we simply mean the opposite, or something being turned upside down. So in indices, reciprocation, if I have 2 raised to the power -1, I'll write the inverse of it as 1 over 2, still raised to the power 1. Good. So when we say inverse proportional variation, here if one quantity, let's say x, increases, the other quantity, let's say y, decreases, and vice versa. So here, while one is increasing, the other is decreasing. Unlike the direct, when one increases, the other increases. When one decreases, the other decreases. But with the inverse, as one increases, the other decreases, and vice versa. So meaning as the other decreases, the other increases. Very good. For instance, if 4 men can complete a work in just 1 day, then 1 man will complete the same work in 4 days. So if there's a work to be done and 4 men can use 1 day, 4 men can use just 1 day, then let's say we lay 3 of them off, and then just 1 person needs to do that same work. I mean, that person is going to use how many days? 4 days. This is how you do it. So 4 men will complete work in 1 day. Then just 1 man. We must apply. If more, less divide. If less, more divide. While there's an increase, there's a decrease. While there's a decrease, there's an increase. So here it was 4 men increase to decrease. Now you reduce the number of men, so there needs to be what? An increase. So if more, less divide. If less, more divide. So here, if 4 is giving us 1 will give us what? More. But 1 is less, so 1 will give more. So if more, then less divide. 4 by 1 is 4. So 1 man will use 4 days. 2 men will use 2 days. So if 4, 2, then 2 will use how many? So if 4, 1 day increase, there's a decrease. Then when there's a decrease to 2, then you need what? An increase. Instead of 1 day. So if more, less divide. 4 by 2 is what? 2. And that's all right. So that is the indirect variation of proportion. As one increases, the other decreases. How do you write it? Let's say if x varies inversely as y, then this is how you write it. X varies inversely as y. We always write it as a fraction with a common numerator 1. That's why I initially did this. With a common numerator of 1. Then you write it in equational form. Equationally, x replaces by equal to, and your constant k now becomes your numerator instead of 1. Constant k becomes your numerator, k over y. Always it is written as a fraction. Always. With k being the numerator and then the other quantity. Also, if x varies inversely as the square root of y, so x varies inversely as the square root of y, or equationally x is equal to k replaces the 1 over square root of y. Very easy. Now let's try and answer these questions. x varies inversely as y. When x is equal to 1, when y is equal to 10. Find y when x is 4. So let's write the first thing. X varies inversely as y. X varies inversely as y. Don't forget, indirect proportion. Then, equationally, x is equal to k over y. Now, when x is 1, y is 10. So, x is equal to 1, y is equal to 10. Then, let's find the value of what? K. So, if x is 1, y is 10, what is k? So, x is beginning. So, 1 equals k, which we don't know, 10 over y, which is what? 10. So what do? We cross multiply. K times 1 will give me k. 10 1 will give me 10. So the value of k is what? 10. Now find y when x is 4. So x is 4, k is 10, but y is unknown. Using the same equation, x here is 4, k 10 over y, which is y, which we don't know. Yes, so y. Cross multiply. 4 times y is 4y. 10 times 1 is 10. Divide both sides by 4. So y is equal to, so 2 into 10, 5. 2 into 4, 2. Which is the same as 2.5. 2.5. 5 over 2 or 2.5. That is all. I'm going to go very, very easy and simple. Yes. Believe you are following. Yeah. So that's the answer to the question. Let's go to the second one. Y varies inversely as the square of x and y. Y varies inversely as the square of x, and y is equal to 100 when x is 3. A. Find the relationship between y and x. So y varies inversely as the square of x. Let's write that statement. Y varies inversely as the what? Square. Not square root. Yes, as the square. Equationally, y is equal to k over x squared. So the relationship between y and x is that y is equal to k over x squared. So this is your A. That's the relationship. Always when they ask you your relationship, this is what they are demanding from you. B. Find the value of x when y is 25. So y is equal to 25. X, which we don't know the value of x. Okay, before that we didn't find k, sorry. So let us look at that. So we know that in the A. So we'll say y, okay, so here y is 100, x is 3. Y 100, x 3, k we don't know. So y is followed by 100, k which we don't know, x squared, x is 3, so 3 squared. Now, cross multiplication. So k is equal to this, we have 100 times 3 squared is 9, so k is equal to 900. So, what is the relationship now? Now we'll see y is equal to 900 over x squared. Since we know the value of the k, we'll leave it here as a relationship. Then B, find x when y is 25. So y is 25, x we don't know, k is 900. So using the same equation, so y 25, 900 over x squared, which we don't know. So we cross multiply with 25, x squared is equal to 900. Divide both sides by 25. x squared is equal to 900 over 25. Let's start 900 by 25. 25 into 90. 0 is 75. 4 will be 100. So 3. 75. 10 minus 5 is 5. 8 minus 7, 15. That does equal to 25 into 150. Let's see. 4 is 100. 5 is 125. 6. Yes, I think 6. 25 by 6. 30. 12. Yes, so 6. 25 times 6, 150. So x squared is equal to 36. We want to find x, so the root of x. Root of 36 is 6. 6, 36. Yeah, let's do. Final one. We find y when x is 15. Y we don't know. K constant still. Now, constant of proportionality. So here your y begins. Yes, y begins. We have to find it. 900 all over x squared. X is 15, so 15 squared. So 900 over 15 squared is 225. So 900 by 225. 900, 225. So 225 into this is 4. Yes, 4 times. So the answer is 4. So when x is 15, y is equal to 4. That is all for today's class. Today we looked at variation for SHS 2. We took this opportunity to help assist our SHS 2 students. So we have lesson on variation that will be posted on the YouTube channel, and also I'm organizing a free class for the SHS 2 students on Zoom, WhatsApp, and I'll also be posting similar videos on our channels in Henry's class. So you've chosen the right channel, and thank you for choosing us. There are a lot by choosers. God bless you. We cherish you a lot, and we have more coming your way. Thank you for watching. I'm a humble teacher, Sir Henry, and I'm privileged to take you through this topic. Please kindly subscribe if you've not done so. Comment, share if you have any suggestion, if you have any question, feel free and put them there. But don't forget, I'll leave with you a simple and short assignment on direct and indirect variation. Leave your answer in the comment section box. I'll also leave my WhatsApp number. You can WhatsApp me with the number, or my Gmail account. You can send your answer into it. I'll mark it for you and then we learn. Thanks for watching and have a nice day. I'm out.